Hi, my name is Boris Chen, and I'm going to present our paper from Netflix Research on match cutting, finding cuts with smooth visual transitions. This is joint work with Amir Ziai, Becky Tucker, and Yuchen Description. A match cut is a transition between two shots that uses similar framing, composition, or action to fluidly bring the viewer from one scene to the next. On the left, a cut between an older and younger child wiping their eyes signifies the next scene will be a flashback. On the right is a famous example from 2001, A Space Odyssey. A tossed bone in the air transitions into a spaceship. This single cut instantaneously takes the viewer forward millions of years, bridging together the prehistoric first act with the futuristic second act. A match cut is a much more powerful storytelling tool than a normal cut. They're also used in movie trailers, advertisements, and social media. Match cutting is considered one of the most difficult and impressive editing techniques to pull off. Finding two shots that match together typically involves manually reviewing hundreds or thousands of shots, looking for potential pairs of shots that might match. We present a system to help with that process. Our system takes in a video and generates match cuts candidates in 5 steps. First, we segment the input video into different shots. Second, we run a deduping step to remove near duplicates. Third, we compute representations for each shot using pre-trained video or image encoders. Fourth, we compute pair scores based on a similarity function. And finally, we sort by score and return the top K pairs. Match cuts can be made by matching any number of visual or auditory elements, such as action, composition, or sound. But in this paper, we focus primarily on 2 types: matched framing of characters and motion-based match cuts. For frame match cuts, we use instance segmentation to obtain instance-level binary masks. In one approach, we take the union of masks and use intersection over union as a similarity function. In a second approach, we preserve the instance-level binary masks for the representations and use instance-level IOU as the similarity function. For motion-based match cuts, we use optical flow to model the motion of each pixel, then average the output across frames to make the distance computation between 2 shots easier. In this visualization, a red pixel is moving to the right and a blue pixel is moving to the left. As a part of our paper, we release an annotated dataset containing 20,000 labeled shot pairs, 10,000 for frame and 10,000 for motion. There are 7 embeddings for each shot, and the shots come from a diverse selection of 100 movies from MovieNet. We use several heuristics described in the paper to surface good candidate pairs to label. We benchmark our system in 2 setups. First, a binary classification setup, which is simple but does not scale well if you want to consider match cuts across many different shows or seasons. And second, a metric learning approach, which offers better scaling with approximate nearest neighbor methods on the learned embedding space. Here are a couple examples. The one on the left is from 1899, and the one on the right is from Partner Track. In conclusion, we have defined a novel task of identifying match cuts, present a system to identify good match cut candidates, release an annotated dataset of 20,000 shot pairs, benchmark our system, and release code and data. In the future, we hope to look into other types of match cuts, better representations, and end-to-end approaches. Thank you for listening.